Deploying software means coordinating many moving parts in an orchestrated way. You're executing Terraform scripts, calling cloud provider APIs, modifying infrastructure components during deployments, running database migrations, deploying to Kubernetes clusters, and much, much more. But all of those tasks need somewhere to execute during deployment and runbook runs, and today I want to explore workers in Octopus Deploy. Workers are dedicated compute resources that execute deployment tasks, the scripts, the API calls, and steps that make your deployments happen. The easy way to think of workers is that they sit between your Octopus server and your deployment targets, handling the work defined in your processes. This separation to a worker improves security by keeping execution tasks off your Octopus server. It enables better scaling by distributing work across multiple machines, and gives you flexibility to configure different worker environments for different deployment requirements. I'll do a separate video on deployment targets, but when getting up to speed with workers, it's worth understanding the distinction between workers and deployment targets. Deployment targets are where your applications ultimately run, the web apps, the virtual machines, and the Kubernetes clusters, etc. Workers are the machines that do the work of executing your deployment and runbook processes and deploying to those targets. They're running the scripts, calling APIs, and deploying packages. Now, behind the scenes, workers and deployment targets are both tentacle agents. The main difference is how they're registered in Octopus. Deployment targets are registered to environments, which you then specify as the target in your deployment process, while workers are registered to worker pools. Let's talk about the types of workers we have, starting with the built-in worker. If you're running the self-hosted version of Octopus Server, you have a built-in worker that runs directly on Octopus Server. It works out of the box with no configuration needed, which is fine for getting started or trialing Octopus, but it means deployment tasks are executing on the same machine as your Octopus Server, which has security and performance implications. We definitely recommend moving to external workers for production use, and more on that in just a moment. And you can also disable the built-in worker in the configuration options of the Octopus Server. Next are dynamic workers, and Octopus Cloud uses dynamic workers by default. These are managed by us, providing on-demand Ubuntu or Windows machines that execute your deployment tasks. You don't need to provision or maintain them, and they're included in your Octopus Cloud subscription. Finally, both cloud and self-hosted customers can configure external workers. These are machines you provision and manage and are registered with Octopus and are assigned to worker pools. These are Windows or Linux machines, or more recently, we have brought in a Kubernetes-based worker as well. Now, I mentioned worker pools there a few times, and pools let you group workers by their purpose, maybe different operating systems, different versions of tools, or workers that have specific network access to different deployment targets. You might create pools for different cloud regions to co-locate workers where your deployment targets are, or pools with different network access for deploying to development versus production targets. When you run a deployment or runbook, a worker is leased from the appropriate pool, which is configured in the process, the work is done, and then the worker is returned to the pool ready for the next task. Now, normally with workers, you need to install and maintain all the tools that your deployment processes require. Things like the Azure CLI, AWS CLI, Terraform, kubectl, different language runtimes. You get the idea, these can build up quickly. And managing these dependencies across multiple workers can quickly become a maintenance burden, especially when different teams need different versions of the same tools. This is where a feature that I love comes into play, which are execution containers. So instead of installing and maintaining dozens of tools directly on your workers, you can configure steps to run inside Docker containers that have exactly the dependencies that you need for the deployment. We provide worker tool images with common deployment tools pre-installed, which might be a great starting point, or you can build your own custom images and put in the tools that you need for your deployments. The container image is specified in the deployment process, so you can control when the tools get updated, and different teams can use different tool versions without conflicts. Now, to round things out, there's a few good practices we've helped customers with when it comes to workers and scaling in production. First of all is, yes, the good old naming conventions for your workers and the pools, so it's easy to understand what they're being used for. You should also configure workers in the same cloud regions as your deployment targets to reduce latency, but also reduce the amount of data being transferred, because we know the cloud providers are great at charging you for that bandwidth, right? And for redundancy, maintain at least 2 workers per pool that you create, and whenever possible, use execution containers that I just mentioned to minimize what you need to install directly on the workers. As usual, if you want to go deeper, there are more resources below. Thanks for watching, and I'll see you in the next one.